Alright, this video I'm going to talking about finding the asymptotes of this function here. So it means that we are going to consider about the horizontal asymptote and vertical asymptote. The vertical and the horizontal asymptote. So as you in the video, in the previous video about the evaluation of limits for the cases of infinity over infinity, right? So find the limits at infinity. When the limits of infinity approaching a value, that value will be your horizontal asymptote. Okay, please refer to the video I talking about limits at infinity. So for vertical, it will be infinite limits where you have a number divided by a zero, right? As the denominator cannot zero. So these two videos I already discussed during when I discuss about infinite limits. Please refer to the video of infinite limits, and this one is the limits at infinity, right? You have to watch this video first. You have to watch these two videos first before you going to for this video now, asymptotes here. So to explain about asymptotes, so you need to consider at first, I want to know how many asymptotes we have here. So first we have to consider vertical asymptotes. So in this video, I'm going to talk about the vertical asymptotes for these cases. So vertical asymptotes is you cannot have zero in the denominator. Whereas for this case, x cannot be 2. X cannot be -3. As you know that when x is 2, you are getting a number divided by 0, right? Which is undefined. So for this type of cases, you will produce a vertical asymptote. -3 also, -3 plus 3, you're getting over 0, right? So it's a vertical asymptote. So to verify that this is your vertical asymptotes, you have to find the limits to the right and to the left. To the right and to the left of this function, right? For example, I have shown you how to evaluate this type of function in the video of infinite limits. So please refer to that video so they have better understanding here. So 1 over with x minus 2, x plus 3, right? So this type of cases, I have already tell you the answer for case where a over 0, right? This is a number divide 2 minus 2, 0, right? It's a 0. So this type of cases, the answer is always infinity. The limits is always infinity, which we said infinite limits. The infinite limits. So now, positive or negative? In this video, I have already tell you how to evaluate. So again, I revise here. So you know that 1 is a positive number, right? It's a positive number. So 2 plus 3 is a positive number, 5, right? 2 plus 3 is positive number. So this 2 is positive. This is positive or negative is decided by this one. But you cannot substitute 2 here, as 2 minus 2 you're getting 0, right? So but this is not 2, it's more than 2, right? More than 2. So you can choose a number that more than 2 from the right. From the right, from the left. So from the right you can have 2.1, 2.2, all right? From the left you have 1.9, right? From the left, from the right. So if 2 plus from the right, maybe you can choose 2.1. 2.1 minus 2. Of course you're getting a positive number, right? 0.1 positive number. So everything is positive. So of course here will be positive infinity. Alright. So how about 2 from the left, right? 2 from the left here. So this one positive. 1 of course will be positive. And this one also 2 plus 3 will be getting positive. But 2 from the left. So you're choosing 1.9. So 1.9 minus 2. 1.9 minus 2 is a negative number. Negative number. So you're getting negative infinity here. So you have shown that when they approaching 2 from the right, you're getting infinity, right? This is enough. With this one is enough to prove that x equals to 2 is an vertical asymptotes here. So, but I do to prove both sides here. So this one you go to negative infinity. So later I can use this information to sketching the graph. So now, okay, you have to jot it down, okay? So this video is I'm going to talk many things. So now about x equals to negative 3, right? So for each, I go for right and left. So for this one also, I have to go for right and left. So x approaching negative from the right and x approaching negative 3 from the left, the one-sided limits here. So then you have 1 over x minus 2, x plus 3. 1 over x minus 2, x plus 3, right? So it's the same case here. You one positive number, right? It's a number, you know, number. So when divide negative 3 plus 3, you're getting 0. Means it's the case of a number divided by 0. This is the case. This type of cases, the limit is always approaching infinity. It's always approaching infinity. So it's either positive or negative, right? So now you have to consider negative 3, right? Negative 3 from the right, negative 3 from the left. You have left and right. So something that greater than negative 3, but don't choose, some students may choosing negative 4, but it's not a very good, okay? It's not a very good approach here, even though we're getting the answer also. So you have to understand negative 3 is something very near, like negative 2.9. Negative 2.9 is greater than negative 3, right? And you get negative 3.1. So it will be smaller than negative 3, right? To the left, to the right. So in your mind, you imagine if negative 3 plus means this is the value. So now, okay, negative 3. This one, you substitute negative 3 minus 2. You're getting negative 3 minus 2, you're getting negative 5, which is a negative number. This one, you're getting 0. So you don't substitute, but you're choosing a value from here. Negative 3 plus negative 2.9. Okay, imagine that negative 2.9 plus 3. You are getting a positive number, right? You are getting a positive number, negative 2.9 plus 3. You're getting positive 0.1. So it's a positive number. But positive, you get positive. But positive multiplied with negative, we have negative infinity here. This is the way we decide the sign. This one also positive. Negative 3 minus 2 also negative, right? But finally, this one you get 0. So you cannot decide. So you have to choose a value that to the left, negative 3 minus to the left, less than negative 3, negative 3.1. All right, imagine that negative 3.1 plus 3, you're getting negative 0.1. It's a negative number, right? So negative, you get positive, so you get positive infinity. So I tell you again, as long as you prove either you go the right to the left, either one, you're proving going to infinity, it's negative or positive, doesn't matter, then you can confirm that x equals to negative 3 is also a vertical asymptote here. So you have how many vertical asymptote here? You have x equals to 3 and x equals to 2, negative 3, all right, negative 3 and x equals to 2 are the vertical asymptotes of this function here, I can rewrite this one as fx, all right, of fx. So now, while you're watching this video, please jot it down everything here, because later I'm going to use all the information here to sketching a beautiful graph, all right? So, but now we are finished in finding the vertical asymptote, but we still need to find the horizontal asymptote to complete a graph here. So let's see how to find the horizontal asymptote. Alright, now, okay, this one is a vertical asymptote. I'm recording here, I'm writing here. Just now you have to look back the video. If the limit as x approaching 2 plus, the limits of the function, you're getting positive infinity. From the left, you're getting negative infinity. From the right, you're getting negative. From the left, you're getting positive infinity, right? Just now I evaluate to finding the vertical asymptote. Now this is the outcome here, right? So I know that x equals to 2 is a vertical asymptote, and x equals to -3 is a vertical asymptote also. Both of this is a vertical asymptote. Now, after finding the vertical asymptote, I'm finding the horizontal asymptote. Horizontal asymptote, we have to find the limits at infinity. Refer to the video for talking about limits at infinity, where you have to evaluate the limits at infinity. At infinity. So 1 over for this function, limits at infinity for this function, and also the limits at negative infinity for this function. So 1 over x minus 2, x plus 3. So this is called limits at infinity, right? But for these cases, very simple. It's a very easy here. So limits as x approaching positive infinity. So for these cases here, if you doesn't need to expand, because this is a constant here. This is a constant here. We don't need to using the techniques of divide by the highest power of the denominator, because this is not x at all. This is just a number, right? So this is a number. So what happened when you divide by 0? When you divide by 0, when you divide by infinity, a number, this is a number now, right? Limits at infinity, when this is a positive infinity, infinity minus 2 is still very big, infinity plus 3 is very big. When you multiply, you're getting even bigger, right? A number divided by infinity, you are approaching 0. Means that the limit of this, you are approaching 0. So same thing for here. So you are still getting 0. You know why? You have a number, then this is infinity, multiply infinity, you're getting very big number. So a number divided by something very big, you're getting 0, right? So it means that both limits at infinity, you're getting the value of 0. Means that y equals to 0 now is a horizontal asymptote. It's a horizontal asymptote. So there are 3 asymptotes in these cases. 3 asymptotes. One is horizontal asymptote. X equals to 2 and x equals to 3 is the vertical asymptote. Alright, now I have enough information here to sketching a graph. Alright, but it's not perfect. Alright, it's not perfect yet, because we just study limits. We need the knowledge of calculus, everything, differentiations, all the knowledge involving differentiations to complete this graph. So now, but we still can sketching the graph by using the limits. We can see the shapes. So how is it? This one is for your knowledge. Alright, for your knowledge. So let's look at how was the graph look like. Alright, you can try sketching the graph first. So a good student is always a student that want to discover what they learn. So this is the way we study mathematics, the attitude of study mathematics. So now 0. So now first you have 2 vertical asymptotes, right? You have x equals to 2, means 1, 2. Then this is your vertical asymptote. So this is a line of x equals to 2. It's a vertical asymptote. So there is another one, will be x equals to -3. -3. So -1, -2, -3. So here will be another asymptote here. Alright, this is a 2 vertical asymptote and 1 horizontal asymptote. Y equals to 0. Y equals to 0 is actually your x-axis. Means the x-axis will become your horizontal asymptote. So now how we using this information for vertical asymptote to see how the graph, the flow of the graph here. So when 2 plus means, if you have 2 plus means right, 2 means left. So when you have 2 plus to the right of 2, this line, right and left, the right, they were going to positive infinity. Means the graph will be going positive infinity. Going positive infinity. Alright. So when it's from the left, you're getting negative infinity. From the left, negative infinity means the y value approaching the very big negative number here, means approaching very big negative value here. Alright, so we're going this way, going this way. So this is to tell us how's the graph go. So negative 3 plus, negative 3. So to the right, to the left. So to the right, you're getting negative infinity. To the right, negative 3 to the right, right and left, you're getting negative infinity, right? From the result just now, when you find vertical asymptote, so negative infinity. So then during negative 3 to the left, you're getting positive infinity. To the left, so means that y getting positive infinity, the graph will be flow this way, right? Positive infinity. So okay, then now you know that how the graph go, but you need the information for horizontal asymptote. Horizontal asymptote means that just now you have find the value of limits when x approaching positive infinity. For these values here, you are getting 0, right? Means that when x going to positive infinity, x become very big. What is the meaning here? Means that as x value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 keep on moving very far. So the graph will be approaching 0, approaching the x-axis here. So means that this graph, so it will approaching the x-axis. When it's at positive infinity, it will be approaching y equals to 0. That's the meaning. Alright, same thing here also. So as the graph approaching negative infinity, you also approaching 0. Means that this graph will be approaching 0 at negative infinity. This is negative infinity, right? So it will approaching the graph. So this is the shape of the graph. And how about this one? Can you see that? Approaching negative infinity. So that's why I said you need the knowledge for dy dx, alright, stationary point, alright. So something happened here. So where the graph will be going negative infinity, means that there will be a turning point here, somewhere around here. There will be a turning point here, because the graph will be intercept the y-axis. Intercept y-axis, x is equals to 0, right? So x is equals to 0, 0, right? 0. So you have negative 1 over 5, which is negative 0.2. Means they will intercept the y-axis as well. Means that there is a turning point here to make the graph to flow in this way. So, but with the knowledge of limits, you can know the vertical asymptote, the horizontal asymptotes. You know how the graph go. But with the knowledge of differentiation and limits, you are even powerful. You will know the stationary point. So, which you will learn during your calculus at university. Alright, that's all for this video. I was talking about asymptotes here. In the next video, I will going for another types of function and how to find its asymptotes.